Hello, 121 students. So this is going to be chapter 7, functions of two variables. So we've been dealing with functions that have the form of f of x, and f of x is just a function that lives in two dimensions, 2D, because we only have two variables, x and y. So y and x, right? So y depends on x. So we have something that passes the vertical line test. This is what we've been beating to death. You learned in algebra, and you've also learned here. So there's only two variables to really consider, x and y. And what we're going to do now is we're going to extend this idea of functions to 3D space. So now we have a function that depends on two variables, x and y, and we have our third function, z. So when we think about functions in three dimensions, don't worry, we're not going to graph anything, but just to give you an idea, we now have an additional axis, x, y, and z. So you can kind of think about x and y as the lower part and then z as the top part. So we're going to be dealing with these types of functions. Now z is going to be relying on two different variables. So the domain of the function is the set of all ordered pairs x and y for which it is defined. And the range is now the resulting values of the function. So you can think about x and y now is going to be my input. My inputs now are all the possible values of x and y. So if you remember from 2D, all the x values, okay, for which the function was defined was my domain, and my range was all my y values. Okay, all my y's was my range. Now, when we think about 3D, x and y, both of them, the combinations of x and y are now going to be my domain. So all of this guy is now going to be my domain. My range now is going to be my z, which is going to be the new y value, if you think about it that way. So here I gave you guys a little bit of a review. So this is just for you to kind of remember. So in college algebra, you learn a lot of different rules on how to find the domain of a function. So I'll let you read this on your own. So we have these guys for polynomials, rationals, radicals that are even, radicals that are odd, exponentials, and logarithms. So these are going to be the functions and how you find their domain. So I'll let you read that on your own. So in the case of this 3D function, z equals f of x comma y, we don't really write the domain in an interval notation. We write it in set builder notation. And this is kind of what set builder notation looks like. And what this means is all values of x and y such that, and then you write whatever the domain is, whatever the domain might be. Okay, so let me kind of like put in color what that means. So this x and y right here is corresponding with this, all values of x and y. That's kind of how you read it. Then you have this little straight line right here, the straight line. That straight line corresponds with such that. That's what that means. And finally, we have this empty space, which is going to be the domain. Whatever the domain is going to be, you're going to plug in there. Okay, so let's do a couple of examples. So keep this in mind. This guy is going to help us out. Okay, so first we want to, you're given these functions of two variables, and we want to find the domain and write it in set builder notation, which is basically this top part. So what do we see? So we see a couple of things. The first thing is that I have x squared. X squared in this case will be considered a polynomial. And we know that if we go to polynomials, polynomials have a domain of all real numbers. Okay, so you can plug in anything that you want in there. Okay, and now the other thing that we have is an exponential. So we have an exponential in here. And if we look at exponentials right here, we can see that all exponential functions have all real numbers, okay? So all we really have is all real numbers and all real numbers. So that means that the domain in this case is going to be all real numbers. So what you can write just is all real numbers. That will be the domain of this guy. You can plug in any x and y value that you want in there, and I'm always going to get a z value. Okay, what would be the second one? So you have 1 over xy. So notice here we have a rational. Okay, so if you go up here, you have a rational because you have a ratio of numbers. Notice that when you have a rational, you're going to set the denominator equal to 0 and solve and exclude that point. So our denominator in this case is xy. So we're going to get xy equal to 0. And notice that this is just going to give me two answers, x equals to 0 and y equals to 0. And what it says when we have rationals is that we're going to exclude that point. So we're going to say that these are not able to be in the domain. So you can, and it doesn't make sense, right? Because if I plug in 0 on the bottom, I just get 0. Okay, so what I'm going to write, let's write it in set builder notation. So I'm going to write first curly braces. Okay, that's what we have at the ends. Then we're going to write x and y. And then we're going to write, so all values of x and y such that, so that's the line. And what we're going to put in there in the second part will be what we just found. X is not equal to 0 and y is not equal to 0. And that would be my answer. So this is how you would find it. It's fancy notation for the domain of this particular function. Okay, how would we find this next one? F of xy equals 1 over square root of x squared plus y squared equals 16. Okay. So the first thing that we want to do is notice that we have two different things. We have a rational and we also have a square root. So a radical. So we kind of have a combination of both. So let's first start off with the square root. So remember with the square root, and remember that it's even, if we look at even square roots, which is right here, it tells us that we're going to set the inside of the square root, the radicand, greater than or equal to 0, and then solve. So the inside of the square root in this case is going to be this x squared plus y squared minus 16 greater than or equal to 0. That's the first thing that we're going to do. But notice that we're not done yet, because notice that this guy is also a rational. And what rational means is that you're going to set it equal to 0 and exclude it. So that means the thing that's in the bottom cannot be 0. So all we're going to do is that I'm not going to set it equal to 0 anymore, because whatever I get, that has to be excluded. So I'm just going to go ahead and get rid of it. Okay. All right, and now all I got to do is solve. Typically, at this point, you can stop. But if you want to proceed a little further, I'm going to add 16 over. X squared plus y squared is greater than 16. And you can just stop there. You don't need to continue on. This is just a circle that we're looking at everything outside of this circle. So you can just leave it as is. You don't really need to solve it if you don't want to. So let's just write it again. All values of x and y such that, and then what are we going to put in there? This x squared plus y squared is greater than 16. We're going to write that. Okay, remember that the reason why we got rid of the equal sign was because it cannot equal that, because we're going to exclude whatever that is. So we're just going to get rid of it. We're not even going to do it because that it's just going to be equal to that. We're not going to get that. Okay. All right, now let's do this part D. So f of x comma y equals square root of x plus 1 divided by y squared minus 5. Okay, so notice that you have two different things. Again, you have a rational and you also have an even radical. So let's deal with the rational first. The rational that's on the bottom, you're going to set the denominator, solve it, and then exclude it. So one of the things that you can do is just set it not equal to each other. That way you can kill two birds with one stone. So we're going to solve for y. y squared does not equal to 5. I'm going to take the square root to both sides. And when I add square root, I'm also going to add plus or minus. So you get y is not equal to plus or minus square root of 5. So that dealt with the rational. And now let's deal with the even radical. So the even radical, what we're going to do is we're going to take this radical, the inside of it, and set it greater than or equal to 0. Solving for x, you get x is greater than or equal to -1. So you got two different answers, this guy and this guy. So let's write it in set builder notation. So it's going to be all values of x and y such that, and we're going to put in both things in there. I like to put my x's first. X is greater than or equal to -1, comma, and this guy, y cannot equal to plus or minus square root of 5. So all of the possible domains, you're just going to combine them together and just put it in all in one. All right, so that's how you would do that one. Now we can also extend this idea to 4 dimensions as well. So if you wanted to look at 4 dimensions, so now you have 4 variables, x, y, z, and w. This is now in 4D. You could still do it. Now the domain will be all possible values of x, y, z. So for example, what we would write in set builder notation will be x, y, and z, such that, and then we're going to write the domain, whatever that may be. And it'll be in terms of x, y, and z. Okay, so let's do this last problem. So find the domain of this multivariable function. All right, so let's deal one piece at a time. So we got a couple of things. The first thing is that we got this logarithm. So how do we deal with the log? So if you go back up to look at how we deal with a log, it says that you're going to set the argument, the inside of the log, greater than 0 and solve. So I'm going to take the inside of the log, which is z minus 7, set it greater than 0. When I solve it, I get z is greater than 7. So that's my first domain. These are the values that z can only take in. All right, and now in my second one, now let's go ahead and deal with the square root of 7, or the 7th root. So notice that we have a radical. And in this case, this radical is odd, because it's the 7th root. So you can see that x is going to be all real numbers. So for x, we get all real numbers. And then finally with y, with the y values, we got a rational. We got something in the denominator. So we got a rational. And what we want to do for that guy, we want to set it equal to 0 and solve, or not equal to 0 and solve. So one way that I can do this is factor. So I get y, you get 3, and then you get 2. Okay, and you can see that the way that this can work is if this guy is negative and this guy is positive. So we get that y minus 3 is not equal to 0. Y plus 2 is not equal to 0. So we get that y cannot be 3 and y cannot be -2. So now that we got all of the 3 different things, let's put them all together. So we're going to write all values of x, y, z now, because we have 3 variables, such that, notice since x is all real numbers, we don't need to write anything for x, because x can be anything. Okay, so we don't really need to put it in here. All we just need to put in is whatever y cannot be and whatever z cannot be. So y can't be 3, and y can't be -2, and also z has to be strictly greater than 7. So if I write it like this and there's no x, then I am assuming that x is all real numbers. Unless x is something different, then I can go ahead and write down whatever x shouldn't be. Okay, so that's how you find the domain of these functions, multivariable functions, either in 3D or in 4D.